Hello, I am Mrs. Edwards, and today we're going to do a variety of things, starting with converting degrees to radians and then radians back to degrees. We're going to graph a few angles and then ultimately use coterminal angles to evaluate trig functions at really big or really small angle measures. So let's get to it here. Let's start off with a conversion that you are probably familiar with. If I wanted to convert 3 feet into inches, really any conversion at all, you want to think of two things that are equivalent to one another that have the labels that are involved. So here we have feet and we have inches. So thinking about feet and inches, we know that 1 foot is equivalent to 12 inches. So all you need to do to convert is multiply by a fraction of equivalence. Now the question really remains, should I multiply by 1 foot over 12 inches, 1/12, or should I multiply by 12 inches over 1 foot, so multiplying by 12? Now to answer that question, you just think about your labels. You're starting off with feet and you would like to get rid of feet. So the feet need to be in the denominator so that we can cancel out the label feet, telling us that we should multiply by 12 inches over 1 foot and not 1 foot over 12 inches. Right? The foot label cancels off there, and now we can multiply straight across, and we end up with 36 inches. We're going to do the same thing with converting from degrees to radians. You want to think of a couple of measurements, one in degrees and one in radians, that are equal to each other. So hopefully you're thinking pi is equal to 180 degrees. So to make this conversion, we just need to multiply by a fraction with pi and 180 degrees. So should we multiply by pi over 180, or should we multiply by 180 over pi? Thinking about the labels, we're starting off with degrees and we want the degree label to cancel. So we need to put the degrees in the denominator so that those labels cancel out. That tells us that we should multiply by the fraction pi over 180 degrees rather than 180 over pi. Okay, now all we do is do that multiplication. When you multiply across, multiplying straight across there, the degrees canceled out, those labels, and then we could simplify a bit further. I could divide the numerator and denominator by 45, and we end up with pi over 4. So 45 degrees is equivalent to the angle measure pi over 4. Doing just a couple more, 90 degrees, we're starting off with degrees, so we multiply by pi over 180. The degree labels cancel, degrees in the numerator, because that's 90 degrees over 1. The degrees cancel, multiplying straight across, we have 90 pi over 180. Divide the numerator and denominator by 90, and we end up with pi over 2. So 90 degrees is equal to pi over 2. One more, multiplying 405 degrees by pi over 180 degrees. The degree symbols cancel out, multiply straight across. Now, you might know off the top of your head the largest number that fits into both the numerator and the denominator. If you don't, it's okay to just think of a smaller number that fits into both and take it one step at a time. 405 and 180, they end in 5 and 0. So you might think, oh, I'll divide them both by 5, giving us 81 pi over 36. But we can still divide these by 9, and that takes us to 9 pi over 4, and it's completely simplified. So 405 degrees is equivalent to 9 pi over 4. We can do the exact same thing, just in the reverse order. I'm starting off with an angle measure in radians. So to convert to degrees, we would like to get rid of radians and we would like degrees. So we want to multiply by 180 degrees over pi, because the degree label will still be in the numerator when we multiply across, and our radians will cancel. Okay, so pi cancels after we multiply across. Thinking of a number that fits into both 180 and 4 fits into both, and so we end up with just 45 degrees. 9 pi over 4, converting that into degrees, so we want to multiply by 180 over pi. I multiplied straight across. The pi's cancel out, and 4 fits into 1,620, 405 times, so we get 405 degrees. Before we move on to evaluating some trig functions at angles that are really large and really small, I want to take this opportunity to remind you how to graph an angle, and then specifically in degrees and really emphasizing radians. Okay, so 45 degrees, if I wanted to graph 45 degrees, since it's a positive angle, you want to rotate counterclockwise. You start there with the initial side there on the positive x-axis, and then we rotate that ray counterclockwise 45 degrees, and there we have the terminal side. So there's our angle measure, 45 degrees. When it comes to radians, most people take the radians, convert it to degrees because you're more comfortable in degrees, and then graph the angle. And if you want to do that, that's absolutely fine. But the last lesson we just had, the last video lesson, we talked a lot about graphing an angle that's in radians. So I'm going to approach this a little bit differently. I want to just simply emphasize that radians means how many radii, or you take one radius, two radius, but plural radii, how many radii will fit along the outside of the circle. So I start there at my initial side there on the positive x-axis, and I'm going to come over here, and what is pi divided by 4? What is 3.14 divided by 4? It happens to be about 0.8. So that simply means that we want an angle measure that encompasses an arc length that is a little bit less than 1 radius. A quick reminder, right there is 1 radius, there's 2 radii, 3 radii, which is why that takes us to 3.14. So 3 radii, we're a little bit shy of a half circle. And we only want to go a little bit less than 1 radius, because 0.8, a little bit less than 1 radius. So if we do that, we go a little bit less than 1 radius, 0.8, then the angle that captures that span is right there, right here to here. And I wouldn't have to convert to degrees. Let's do one more like that. 405 degrees, graphing that, 405 degrees. We start our initial side there, positive x-axis. We start rotating, but we're going past where we started because 360 degrees is a full circle, and we're going to have to go an extra 45 past 360 to get to that 405 mark. But once we do get to 405 degrees, and you use these spiral arrows to say this is where I started, and then you just start spiraling around until you get to that terminal side, and there we have the graph of 405 degrees. If I do this in radians, yes, of course it's going to be the same because we know 405 degrees and 9 pi over 4 are the same. But just thinking about this a little bit differently, 9 multiplied by 3.14 divided by 4 is about 7.1. So we just need to go around on the arc length. We need to go around a little more than 7 radii. A full circle is a little more than 6 radii. So we're just going to go 1 radius more than a full circle for our sketch. So here's our initial side, going 1 radius, 2 radii, 3 radii, 4 radii, 5 radii, 6 radii, we're almost full circle, and then 1 more radius, and we stop right there. So the angle measure 9 pi over 4 stops right there. There's that terminal side, and it still would loop around 1 full circle and a little extra. So these two are equivalent. Since we have the graph of 405 degrees, or 9 pi over 4 here, let's make an observation. See how we have the initial side. Get my highlighter here. We have our initial side, and when we rotated 405 degrees, this side right here is the terminal side. It's where terminate means to stop. So it's where this angle stops rotating. So there's our terminal side. Now, the angle measure 45 degrees would have the exact same terminal side. The only difference between the look of graphing 45 degrees and the look of graphing 405 degrees is this spiral right here. Graphing 405 degrees, I start my spiral, I go a full circle and a little more, and that indicates 405 degrees. If I was graphing 45 degrees, I would start with the same initial side, and I would have the same terminal side. The only difference is this spiral would not go so far. It would start here on the x-axis and just go up to here and stop. So the only way you can tell that is 405 versus 45 is how far that spirals. Okay, but when you take a look at a coordinate on the unit circle, if you're at 405 degrees or if you were at 45 degrees, the coordinate right there is going to be the same. So what we're going to be able to do is we're going to be able to use that idea to evaluate trig functions of really big angles and really small angles. So let's take a look at an example of using a coterminal angle to evaluate a trig function. We're going to evaluate the sine of 405 degrees using this coterminal angle. But vocabulary is really important because otherwise you don't know what they're asking for. So let's just focus on some words that you probably already know to connect them. How about co-captain? If you were the co-captain of the soccer team, that would mean that you were sharing the responsibility of being the captain. So coterminal means they're angles that share the same terminating side, terminal side. So that one we just looked at, right, 45 degrees and 405 degrees, they look exactly the same other than the spiral because they are coterminal angles. Okay, so 405 degrees, what that amounts to is you can add or subtract as many times as you want 360 degrees until you are between 0 and 360. Right? You want to evaluate a trig function using your unit circle, and it only goes from 0 to 360. So you want the angle measure sitting in front of you to be a number between 0 and 360. To make that happen, you're just going to add or subtract 360 as many times as you want. Now 405 is just a little bit more than one full circle, so I'm only going to need to subtract 360 one time, giving us 45 degrees. Then we go to the coordinate at 45 degrees, which happens to be, when we look at these three dots, This one here is over medium, up medium, so root 2 over 2, root 2 over 2. And sine, the answer to sine is the y-coordinate, because points come in cosine, comma, sine. So the y-coordinate here at 45 degrees is root 2 over 2. So the answer to sine of 405 is the same as the sine of 45 degrees, which is root 2 over 2. Doing the same thing in radians. If you're not sure if you were over 2 pi, 2 pi is 6.28, just quickly multiply 9 times pi divided by 4 and see how far past 6.28 that you are. And we're only a little bit past. 6.28 doubled, 12 point almost 5. You can kind of get a sense of how many times you're going to have to add or subtract 2 pi if you just convert that to a decimal. But nonetheless, we are above 2 pi, so I'm going to need to subtract 2 pi so that I'm on the unit circle. All right, so subtracting 2 pi, we'll get to an angle with the same terminal side because 9 pi over 4 is rotating one full circle and a little bit. So subtract off 2 pi. Now when you subtract, you need a common denominator of 4. So let's multiply 2 pi by 4 over 4. So we have 8 pi over 4. 9 pi over 4 minus 8 pi over 4 is just 1 pi over 4. We go on the unit circle to pi over 4, which is in the same location there as 45 degrees was. So it's at root 2 over 2, comma root 2 over 2. The answer to sine is the y-coordinate, so the answer is root 2 over 2. So please keep in mind, if your angle is much, much bigger than 405 degrees or much, much bigger than 9 pi over 4, you might need to subtract 360 degrees or 2 pi more than once. And the goal is to get an amount that is between 0 and 360 or between 0 and 2 pi. All right, let's do just one more here. We have the cosecant of negative 30 degrees. We want an angle measure between 0 and 360 degrees. A quick reminder of graphing a negative angle. You start there on the positive x-axis, that's your initial side, and when you have a negative angle, you're going to rotate clockwise. So rotating 30 degrees clockwise, there we have a graph of negative 30 degrees. Now because the picture, you can just see, oh, it's the same as 330 degrees. But we're using the idea that if the angle measure we're working with is not between 0 and 360, we can just add or subtract 360 as many times as we want. So if I add 360 degrees, I get 330 degrees, and I am on the unit circle. So go to the coordinate there on the terminal side, and then cosecant of 330. So because it's cosecant, we have to think through it. We are like, okay, what's the reciprocal function for cosecant? That is sine. Now, points, ordered pairs, come in cosine, comma, sine. So sine of 330 is negative 1/2. Cosecant is its reciprocal. So the reciprocal of negative 1 over 2 is negative 2. In summary, if you want to convert degrees to radians, you're going to multiply by pi over 180. If you're going to convert radians into degrees, you're going to multiply by 180 over pi. If you're graphing an angle, if you have a positive angle, rotate counterclockwise, and a negative angle, rotate clockwise. Also remember to put that little spiral and start it on the positive x-axis and then rotate it until you get to that terminal side. Then specifically when you're graphing those angles that are measured in radians, you can convert to degrees and then graph. That's okay if you need to do that. But another idea is to just divide. So if you had pi over 4, you just take 3.14 divided by 4. Divide and make it a decimal, and then you can just estimate how far around you should go, knowing that a half circle is just over 3 and a full circle is just over 6. So you can kind of estimate how far to go based on that. Okay, and then lastly, if you want to evaluate a trig function, sine, cosine, tangent, secant, cosecant, or cotangent of a really big angle, so in other words, an angle that is bigger than 360 or 2 pi, or a really small angle, an angle that's going to be smaller than 0, a negative angle, then simply use coterminal angles by adding or subtracting 360 degrees, one full revolution, or adding and subtracting 2 pi as many times as you need until that angle measure is between 0 and 360. So you're back on that unit circle you're used to. Eventually, we'll also have angle measures that are not on the unit circle no matter what you do. But this is kind of our first strategy, is you want to try to get an angle that you can see on the unit circle by adding or subtracting extra revolutions, as many as you need.